Hi everybody. So today I'm going to talk about 12-2 arcs and chords. I think this one is also fairly straightforward. I do want to walk you through a couple of the concepts at least. So let's look at a couple of homework problems, and please let me know if you have any questions after this. So starting off with number 15. You have the basic property here of arcs and chords. If you have congruent arcs, and for example, right here and right here, those are two congruent arcs, you're going to have congruent chords that are formed by those arcs. So for example, that means that QR and SR here will be congruent to each other. So if you want to find the length of one of the chords, either QR or SR, you just have to solve for it algebraically. And I already set it up right here. And so, for example, I have 6y equals 8y minus 8 set up right there. And it's just really simple algebra here. So I'm going to subtract the 8y, getting negative 2y equals negative 8, y equals 4. And I just have to plug in. The question asks for QR, but it doesn't really matter since they're equal to each other. I'm going to plug it into the 6y because I know it's equal. So 6 times 4 is 24. Pretty easy. Now let's take a look at number 18. There's going to be a few problems. This one's a little bit trickier, but once you know how to do it, not all that difficult. So what do we have going on here? Again, we have a circle. We have a radius of the circle, CD, and we have a chord right here, EF. Okay, an important thing to notice here is that the radius and the chord are perpendicular to each other. When that happens, when they are perpendicular to each other like that, the radius, CD, is going to bisect the chord, EF, and the arc it forms as well, EDF. So this I didn't draw it very well, but that length here from E to D and D to F are the same. And the chord, same idea. Also is going to be split into two evenly. So this problem is asking you to find the length of the chord. Okay? What do they give you though? They give you the radius split into two pieces. You get a 50 piece of the radius, you have a 20 piece of the radius. So the whole radius is going to be 70, okay? 50 plus 20. So to solve this, you have like an intermediate step. So what I did is I'm going to draw a triangle because we're going to use some right triangles here. And I don't have enough information right away to find what that is or what the whole thing is. But what I'm going to do is draw a subsection of it. So we have E here, we got C here. We know C is 50. And I'm going to draw the radius from E to C. So if I put it on the graph, it'd look like this. You know, just like boop, 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 boop. All right? But I didn't draw it because it'd be very, I'm going to erase that because it's kind of messy. It's difficult to see. That's why I drew it separately. So, well, what's the distance of EC? Well, that's just the radius, right? So we got 50 plus 20, and that's 70. Well, now not so bad, right? It's just Pythagorean theorem. Let's set that up. So EC is the hypotenuse. So what do I got? I got x squared plus 50 squared equals 70 squared. And square those out. So we get 2,500, 4,900. Subtract. What's that? 2,400 square root. And that's approximately 49. Now keep in mind that 49 is not the whole chord though. It's only like half of it, right? So to get the whole chord EF, you have to multiply it by 2. Not difficult though, right? So I know EF is going to equal 2x. So, which is going to be approximately 98.0. okay? And that's all it is, really, to it. I mean, it's just a little confusing to set it up, but once you know what to do, it's just a pretty straightforward Pythagorean theorem problem. So, let me know if you have any other questions. There's some earlier stuff in the unit as well. I think those are pretty straightforward, though. If you do have any questions, please let me know, and I'd be happy to go over them with you. So, have a great day, guys, and I'll talk to you later.